In this problem, we're going to be verifying the identity that sine to the fourth x minus cosine to the fourth x is equal to 2 sine squared x minus 1. The first thing that we should do is work with the more complicated side. In this case, it's kind of difficult to decide which side is more complicated, but if you look at the left side, we have exponents of 4, and generally that's going to be more complicated. So let's take this left side and try to break it down. So the first thing that we can do here is notice that we are subtracting two different exponents of 4. If we had something like x to the fourth minus y to the fourth, then we could rewrite this as x squared to the second power minus y squared to the second power. And now this is a difference of squares, which would factor into x squared minus y squared divided by x squared plus y squared. And since x and y are just anything we want, then we can say that x and y are sine of x and cosine of x. Which means in order to factor sine to the fourth x minus cosine to the fourth x, we could rewrite this as sine squared x quantity squared minus cosine squared x quantity squared. Just like we did with the x to the fourth minus y to the fourth, which means this will factor into sine squared x minus cosine squared x times sine squared x plus cosine squared x. The first term minus the second term times the first term plus the second term. And now that we have this, notice we have sine squared x plus cosine squared x. We know that sine squared x plus cosine squared x is one of our Pythagorean identities. And it's equal to 1. So we can substitute that into our identity here, giving us sine squared x minus cosine squared x times 1. And now from here, this just becomes sine squared x minus cosine squared x. Okay, so we still have to work toward getting this 2 sine squared x minus 1. And if you recall, we have an identity that says cosine of 2x, I'll write this off to the side actually, this way it doesn't get too confusing. We have an identity that says cosine of 2x is equal to cosine squared x minus sine squared x. Right here we have sine squared x minus cosine squared x. So if we were to factor out a negative 1 from each of our terms, we would have negative 1 times negative sine squared x plus cosine squared x. And now that's exactly what we need to substitute in cosine 2x into our problem, because cosine squared x minus sine squared x is the same thing as negative sine squared x plus cosine squared x. So this leaves us with negative 1 times cosine of 2x now. And now from here, we have one last identity that we can work with that says cosine of 2x is equal to 1 minus 2 sine squared x. Notice this looks almost exactly like what we needed in the beginning, except the signs are opposite. The 2 is negative and the 1 is, the 2 is negative in our problem and the 1 is positive, but we need the 1 to be negative and the 2 to be positive. So if we substitute this in for cosine of 2x, we'll have negative 1 times 1 minus 2 sine squared x. And if we distribute that negative 1 that we had earlier, we'll get negative 1 plus 2 sine squared x. And that's equal to what we needed in the beginning. 2 sine squared x minus 1. When you're adding, it doesn't matter what order you go in. So negative 1 plus 2 sine squared x is the same thing as 2 sine squared x minus 1. So we have verified this identity.